Welcome to Advanced Java Programming at Portland State University. In this screencast, we'll be learning about unit testing with Java and the JUnit framework for helping you write unit tests. But first, we're going to talk about testing and why it's important. So, testing is one of the most, if not the most important tasks in software engineering. Let's face it, when software is well tested, it's easier to document, it's easier to understand, and it's easier to extend. There's a framework called JUnit that provides a flexible and easy-to-use framework for developing unit tests for Java programs. So, what are we going to talk about in this screencast? Well, we're going to talk about why you should test your code. We're going to look at the JUnit framework, and then we're also going to look at another library called Hamcrest that gives you advanced facilities for making assertions in your unit tests. So everybody knows that they should do tests. They should write tests for their code. But why don't they? Well, hey, there's an excuse of, oh, there's not enough time. However, the less that you test your code, less confidence you're going to have in your code. I mean, how do you know it really works? How do you know it does what you think it should do? So I am asking you to break the vicious cycle of untested code. Don't wait until you think you have all of the functionality implemented before writing the unit tests. Write your unit test as you code. As a matter of fact, I would encourage you to write your tests before you write the code, before you write the implementation. And every time you add a new piece of functionality, it should have its own test to verify that it works. This is called a unit test. A unit test tests a very small little bit of code, often a method or maybe a particular interaction with an object. And if you have a suite of unit tests written, you should run your tests every time you recompile. Make a change, run your unit test. Unit tests run really quickly, and they'll give you instant feedback and continuous confidence that your code is doing what it ought to. Before we dive into the details of unit testing, I want to take a slight detour through some history and talk about extreme programming. So back in the mid-90s, Kent Beck and a bunch of his cohorts began evangelizing something called extreme programming. So the whole idea behind extreme programming is that software needs to be developed very quickly and needs to evolve even faster. In the mid-90s, the internet was coming of age, computers were getting much faster. People realized that there was a competitive advantage to being able to develop software quickly and then change it as the customer's needs change or they learn more stuff about what they want. Another tenet of extreme programming is that software engineers should develop together, pair programming, two sets of eyes looking at a problem, people collaborating together. The era of the lone wolf programmer, the guy that sits there in his basement and bangs out code, that's over. That model is seen to be ineffective. It's easy to make mistakes when you're working in isolation, and it just doesn't make for healthy code. Extreme programming also evangelized testing and writing automated tests, and that you should write tests along with the code that you develop. Develop them both at the same time. Don't wait until the end or until you think you're done before writing your tests. Besides programming practices like pair programming and testing practices like writing unit tests, extreme programming acknowledges that it takes a lot of people to write software. So it's not just the guy writing code. There's the architect to make sure that things are consistent. There is the programmer, of course, that writes the code, the manager to help manage the people stuff, and ultimately also the customer who should be involved with writing software. If you're developing software, for somebody, you want to make sure that they're getting what they want. In extreme programming and other agile methodologies, there is constant feedback from the customer, from unit tests, from testers, from advocates for the customer that help ensure the customer always gets what he wants, and that the order in which things done are done in a way that will satisfy the customer. It's also really important that software must function correctly at all times, even if the functionality is limited. So extreme programming advocates starting small. Figure out what's the simplest thing that could possibly work and get that to work. And then have automated tests to make sure that it keeps working as you build up your program, as you build up functionality. Again, extreme programming XP emphasizes simplicity and elegance in software engineering. get things working, right? Demonstrate that the functionality is there, have automated tests that validate the functionality, and then optimize. I personally can attest to projects that I've seen and actually code that I've written where I tried to be too clever too early. And as a result, I pre-optimized things, and I either made things more complex than I needed to be, or I ended up optimizing something that didn't need to be optimized. It's always exciting to look at a new algorithm or try to figure out how we could do things more efficiently. But at the end of the day, we need to get things working and working right, keep them working right, and then efficiency will come as we better understand our problems. So these principles of extreme programming work really well when developing object-oriented software. Thinking about it, classes are extended to add more functionality. This is how you gradually build up things. You can use inheritance. And as you add new functionality, you want to add new tests. But you've got your old tests lying around that make sure that the old functionality still works. So here again, just as I've advocated writing documentation as you go, writing tests as you code has many benefits. You really gain confidence that your code works, that you can make a change and make sure that you haven't broken anything. Everything behaves as it did before. You find bugs in your code before someone else does. And for those of you that are early in your careers, maybe just starting out, making a good impression with your peers, with your coworkers, is important. And so if you've done a lot of testing before you hand your code off to someone else or integrate it with someone else's code, it'll make you look good. Also, by writing unit tests, you become a consumer of your own code. And so you can ask yourself, well, is this code easy to use? Am I writing a good API? Do my method names, my variable names make sense? So you get to test out your code. You get to validate that your code is good. And here again, if you run all of your tests every time you build, you know that your changes haven't broken anything. And I think there's real power in that, the confidence that it brings, and and actually it's confidence that lets you go faster. It lets you try more things, because you'll find out within minutes of making a change that something's wrong, as opposed to hours, days, or even months. Okay, let's talk about this JUnit framework. So Kent Beck and Eric Gama, who's one of the guys that wrote the Design Patterns book way back when, developed a unit testing framework for Java programs called JUnit, and you can find all about it at junit.org. Now, JUnit's been around for a long time. It's probably one of the most proven and useful frameworks for the Java programming language, and that's saying a lot. So just as a little history here. The JUnit framework, JUnit framework package has a simple class hierarchy for developing unit tests. So what there was a base class called assert that had a bunch of methods like assert true and assert equals. Now when you write your unit tests, there are sort of three things that you do. You first set up some data, and then you perform some operation, and then you assert something about that operation. Maybe you call a method and you make an assertion about what you expect the result of that method to be, or you maybe that method updates the state of an object. Then you make some assertion about what that state of the object is. If the assertion fails, the unit test fails. So if you expected some value to be true and it was false, the unit test will fail. And JUnit has a whole framework for capturing these failures and reporting on them. We'll see more details of this in a little bit. Anyway, so you've got assertion. So you've got the assert class, and there's a subclass of that called test case. And test case has a setup and teardown method. Now, setup is a method that is invoked before the test case is run, and teardown is run afterwards. There's also a test suite class, which consists of multiple test cases. And both of these can be run, and it's given and the run method lives on a test interface, et cetera, et cetera. And so what you did is that you would write, and when you wanted to write a unit test in JUnit, you would subclass the test case class, and write your own test methods. Now, a test method is one that is public, returns void, and has a name that begins with test. And this worked really well for a lot of people for a long time. You know, many people used JUnit, liked it, and really it helped you know, raise visibility of automated testing, especially automated testing done by developers. However, there were some things that were kind of awkward. You were forced to subclass test case, which meant that your test couldn't subclass anything else, right? In Java, there's single inheritance of state, anyway, of classes. And so if you wanted to have like your own hierarchy that wasn't necessarily a test case, you were out of luck. And also the naming convention, or the convention of having public void test, okay, that worked out pretty well, but it wasn't necessarily easy to find these test methods. And you know, IDEs and stuff, you could have, you know, a test method in your application, or rather a method that begins with test in your application. You couldn't tell that from a method that was actually a unit test method. So version 4.0 of JUnit introduced some annotations that live in the org.junit package that you then use to denote classes and methods that are unit tests. So for instance, there is an @test annotation. You put that on a method and says this is a test method. So it needs to be public and void. Actually, I don't know if it needs to be void or not. Well, it still needs to be public. But now the name of your test doesn't have to begin with the word test, and this can be freeing in some cases. We'll see some examples later. Note that the annotation, you can say @test, and you can tell what exception to expect. So for instance, you might have a test that is test, hey, when I give some bogus input to a method, it throws an appropriate exception. And so in that case, your unit test is expecting to throw an exception. Other times when it throws an exception that's unexpected, well, the test has an error, and we'll see that in a little bit. So when you annotate your test methods with the @test annotation, you can tell it what exception to expect. You can also provide a timeout for how long you expect the method to run. If it doesn't complete within that amount of time, the test fails. Now, there's no inheritance involved, so no longer do you have setup and teardown methods that you override. Instead, you can annotate methods with @before and @after, and the JUnit framework, when it runs your unit test, will invoke all the methods that are annotated with @before, then run all your test methods, and then it'll invoke all of the methods that are annotated with @after. And before and after do the same things as setup and teardown. Of course, you know, if there's something, if there's some data that you need to initialize before your test runs, you can do that in an @before method. And if there's any cleanup that you need to do, maybe delete temporary files or clean up some data structures, something like that, reset some state, we can do that in @after. So @before and @after are run before and after every method. In your unit test, if you want to run some setup or teardown before or after all of the methods are run, you can use the @before class and the @after class annotations. Now, sometimes when you're writing a test, you want to write your test, but it's not passing yet. That's one of the things about test-driven development, right? If you write your test first, they're not going to pass. And so in test-driven development, there's a life cycle called red-green refactor. So the whole idea is that the first thing you write is a failing unit test, and it fails, and it's red. And after you have your failing unit tests, you augment your application under test, your source code, so that the test pass. So it's green. So red, green. And then once you have a passing unit test, you can then refactor your code, clean it up, maybe spiffing up some method names, maybe moving code around, extracting some methods, extracting some objects, things like that. And since you have a passing unit test, you can rerun it and make sure that it's still passing after your refactoring. So after you've refactored, you start the cycle all over again. You go for red. So you write another unit test that I expect to fail, make it pass, and then refactor. Red, green, refactor. We'll be seeing some examples throughout the course of this. Anyway, once you have one of those failing tests, one of those red tests, maybe it'll be a while before you can get everything running. Maybe you want to write, you discover other unit tests that you want to write first. If you slap an @ignore annotation on a test method, the framework won't attempt to run it. JUnit 4.0 was introduced along with the new Java 5 language features, and another thing to take advantage of in addition to annotations is the use of static import for assert methods. So prior to JUnit 4, you had the assert methods because you inherited them from a superclass. Well, now you just do a static import of them, and you've got them also. So I wanted to tell you about sort of the JUnit 3.x way of doing it and the JUnit 4.x way of doing it, because in your travels you might see examples of both. Now, to show off what it means to write unit tests, we're going to develop a simple application that uses classes for modeling students that are enrolled in a section of a course. Here's a little UML diagram with asterisks that are not showing up very well, that shows the relationship of the objects. So a course is in some department, has a number, and is worth so many credits. And every course is associated with 0 or more sections in a given term in a given year. And you can add and drop students from a section, and you can compute the average grade and get the class size of the section. And a student has a many-to-many relationship with a section has a many-to-many relationship with students. So a student may be enrolled in multiple sections of a course, and a section may have multiple students enrolled in it. And every student has an ID and a map of grades. So this is just a very simple application. You can probably imagine how it's implemented. I'm not going to go into the implementation of this. Instead, what I'm going to show you is how it's tested with JUnit. Okay, so here is a simple test class that validates that, here again, very simple, we're taking baby steps, that when you add a student to a section of a course, the size of the class is 1. So here's how you do that. We'll just skip down the imports, we'll go back to that in a second. We have a public class section test. I like to have a naming convention that the class that tests the section class is called section test. And one of the test methods in this class is called test add student, and I mark it as a test method with the @test annotation. Note that this code follows the old convention of having test method names that begin with test. You can have anything. Actually, probably if I were writing this today, the name of the method that I would use a very long and descriptive method name for my test, something like adding student to a section means class size of 1 or something like that. There's no reason to scrimp on the names of your test methods. So walking through this code very quickly, we create a student, we create a course and a section of that course. We add the student to the course, and that's all the setup. So actually, sorry, the setup of the unit test is creating all these objects, your student, your course, and your section. The operation that we want to test is that we add a student to the section, and then we assert. We will say, well, okay, I assume at this point in the code that the value 1 is equal to the size of the class, of the class size of that section. If the class size of the section is not 1 for whatever reason, the unit test will fail. So let's take a look at some of the import statements. The @test annotation is imported from org JUnit, and note that we have a couple of static imports of these static methods like assert equals and fail, which we'll probably see in another example. Actually, before we do, let's go over to IntelliJ, and I'll run this test because I want to show you how you can run the tests from IntelliJ. Okay, here we are in section test. And So here I am, I'm editing the section test class. In order to run a test method, I can right click on it and I'll get an option for run test add student. It'll rebuild my project, and then down below it gives me a summary of well, the test it passed, and if I double click on this, it'll bring it back here. So let's change the unit test to just see what it looks like when it fails. Let's say that I'd expect that the size of the class section is 2. I can either right click and rerun from here, run from the pop-up menu, or I can go back down here, click the go button, and it will rerun it. And as you can see, so IntelliJ invokes the JUnit framework to execute the test method, and when it does, it gets a failure, an assertion error, because an assertion, the expected value was 2, but the actual value was 1. And IntelliJ gives you a nice view of the difference, and sort of a side-by-side view. For the values 2 and 1, this isn't so interesting, but if you're asserting strings or something, it's nice to have a diff. And the assertion error is a Java exception that's thrown, and you get the stack trace here, which lets you quickly navigate to where the failure was, and you'll see that, okay, yes, I didn't want 2, I wanted 1, and now I'll rerun it, and it ought to pass. So IntelliJ has really nice integration with JUnit. So one way to run unit test is through JUnit, one way to run unit test is through IntelliJ, and as you're writing your code, that's probably how you're going to be invoking them. I just want to touch on the fact that you can run them programmatically. You can write a little command line tool to run them, and you use classes like the JUnit core class from the runner, and what you can do is specify what classes you want to run in your suite, things like this. I'm not going to go into details about this because it's very doubtful that we'll be using that in this class between running unit tests in IntelliJ or your IDE of choice as you're developing, or running them as part of a Maven build. You won't need to worry about this stuff. So it's kind of nice to know about it, but not something you really need to focus on. So assertions are used to validate expected state, but another important thing to test is that your program fails in an expected and well understood fashion. It's nice to test the happy path, and you should definitely have validation of the happy path. But when things go wrong, you want to make sure that things fail in the way that you expect. So if you give bogus input to your method, if you pass nulls instead of regular values, you want to make sure that data isn't corrupted, or that expected things happen. So writing negative tests that test bad things are just as important as writing positive tests that again test the happy path. So here I've got an example that tests that makes sure that when you attempt to invoke the drop student method on a student that is not enrolled in the class, we get an illegal argument exception. And so the way you write that in JUnit is that for your test method, test drop student not enrolled, the @test annotation has an expected value of a legal argument exception .class. We've seen .class a couple of times now. Don't worry, we'll learn everything you always wanted to know about reflection in a later lecture. But for the time being, just take comfort in the fact that if you want to refer to the illegal argument exception class, you do it with that syntax, that .class syntax. Looking at the body of this test method, you'll see that we set up some data. we call student course, we create a student, a course, and a section, but we never add that student to the section. Instead, we just call drop student on there, and the expected implementation of drop student when a student is not enrolled is to throw an exception. And here again, because we've said that we expect the legal argument exception, when that exception is thrown by drop student, it'll pass. If it's not thrown by drop student, the method will fail. Now, let's say that you've got some other logic, and if you get to a certain point, you just want the test to fail. So maybe you perform some operations, and instead of doing an assert to assert some state, maybe you've been able to reach some code or perform some operation that you shouldn't. You can just call the fail method directly, and that failure will be propagated to the reporting framework as part of JUnit, and the test will fail. So if an assertion error, if an assertion fails, the test fails. However, if you get some other kind of exception while the test is running, let's say you encounter a null pointer exception that isn't handled, or you run out of memory or something, the test will fail with an error. So there are three states, after a test is run, there are three states that it can be. It can either have passed, it can have failed because of an assertion error, or it can be in an error state, meaning that an unexpected exception occurred. And these are reported differently by JUnit. Just to go back to our example, here we have our test drop student not enrolled method. We can run it individually, or if you sort of click outside of a test method, you have the option to run the entire test as run section test. It'll run both the test methods and look everything's passing. Okay, I want to go into a little bit of detail about those static methods from the assert class that you can import. So we've seen assert equals, and so then assert equals is overloaded to take all sorts of different kinds of arguments. And assert equals basically says that two entities, whether they be objects, they can be primitive types like ints, stuff like that, ought to be equal. And of course, the way they compare objects is by using the dot equals method. We can also make some assertions about, okay, well, the assertion should be, so a value should be not null. Maybe you don't care what particular string it is, just as long as it's not null. So assert equals compares using the dot equals method, but if you want to do object reference comparison, then you use the assert same method. And if you want to assert that just some Boolean expression should be true, maybe you have a method that returns a Boolean, you could use assert equals true, I guess, but there's also a shortcut, assert true method, that will assert that, well, a Boolean expression should be true. There's also assert false. And again, there's that fail method, which just automatically fails the test method. Each assert method is also overloaded to have a string message associated with it. So the first argument, so assert methods like assert equals either has two arguments, or it has a three-argument variant where the first argument is a message that is printed out with the failure. And this can be very, very helpful, especially when you've got something like assert equals with an int, where it's like, okay, I expected 1, but I got 2. Well, what does that mean, and what's the context there? And so you can add a message to your assertions that when it fails, the message is included, and that helps you understand what it meant for the assertion to fail. Actually, let me just show you an example of that real quick. We'll go back to our test add student, and we'll break it again in the way that we saw it before, expecting the class size to get 2. But we can add a description, if you will, of what this assertion is. So let's see here, class size ought to be 2. And now when we rerun, we'll see that it fails, and the message that we included, the message that we added to the assertion is included in the assertion error. quick, I'll just fix it so that it passes again. I like passing unit tests. And we'll rerun it. Cool, all happy again. So again, your test code is just a regular Java class. There's not that much magic here. As a matter of fact, it doesn't even have to inherit from a test framework class anymore. Instead, you sprinkle these annotations all over it. And again, you can, instead of having set up and tear down methods, you have at before and at after, or methods that are annotated with at before and at after to set up data and then clean up data afterwards. So for instance, maybe you need to establish or disconnect some network resources, or you need to create a database connection or temporary files and things like that. You can annotate a class with suite classes to make it what's called a test suite. And at one time people did this. I think it's kind of fallen out of style. With the way that tests are run these days, you don't need to really group them in suites. I suppose you can sort of say, well, I want all of my tests that maybe exercise a certain component within my my larger application to be in a single suite. But I think I found that most people just use packages to associate that stuff together. And so anyway, but if you want to go read up on @suite classes, feel free. Well, and speaking of packages, so when you are writing your test code, you need to ask yourself, should your test classes be in the same package as the code they're testing, or should it be in a different package? Well, if they are in the same package, your test code can access package protected methods and fields, and that can be nice, right? There might be some functionality in your program that you want to make available for testing, but you don't want to make available for everybody. And one of the ways to do this is to have package private or package protected methods and fields. Using that default visibility. So instead of marking a method or a field as public or printed or private, you just leave it blank. Also, by having your test classes be in the same package as the code they're testing, it makes it easy to associate the test code with the domain code. Right? They sort of have, they're in the same package. They look the same. However, you don't want your test code to interfere with your domain code. Right? Your test code ought to be kept separate. Strictly speaking, your test code isn't part of your application, right? It ought to be separate. It ought to do something different. And certainly, if you are building if you're building software that gets shipped to somebody, you don't want to ship your test code, right? You don't want them opening up your jar file and seeing all these tests in there. You really want to keep things separate. So I don't think there's too much debate about this anymore. So when I write my unit tests, I have a separate directory hierarchy for the test code. And if you bop over to the screencast about Maven, you'll see that Maven also follows this pattern. They have their tests often one directory hierarchy. They still have them in the same package, so you see all the package directories, but they're off with tests, and your domain code, your application code, your code under test is often main. Sorry, a main directory. So JUnit's awesome, and JUnit has just really helped advance the cause of unit testing. But over time, people found that the code and sometimes the failure messages can be kind of hard to read. So, for instance, let's say that you have some operation that returns a string, and you want to assert that the string contains some other string. So it's like my string contains hello. The contains method on a string returns a Boolean, and so you use assert true. Well, in the case in which this assertion fails, what do? You get a failure message that says, well, I expected it to be true, but it got false. Well, that doesn't really help you with debugging, because you can't see what the value of my string and what it was supposed to contain. And it's from observations like this that led some people to write a library called Hamcrest. I don't know what Hamcrest means, but I do know that it's a really helpful library for writing readable unit tests. And so what Hamcrest provides are a bunch of objects called matchers that provide that allow you to build up assertion statements that are more readable than traditional JUnit. And they also allow for much better detailed and specific failure messages. So you can go off to the Hamcrest website and learn all about it. They've got pretty good documentation and good Java API docs, although the matcher stuff involves some magic with generics and stuff like that. So you might your eyes might get a little crossed before we learn fully about generics. But here I've got some examples to show you what I mean. So just the same way that JUnit provides the assert true and assert equals methods, Hamcrest provides a single assert that method that asserts that some value matches what's called a matcher object. And you build these matcher objects using static factory methods. Meaning there's a static method that you call that says, hey, give me a matcher that matches the value 4, or give me a matcher that will match any number greater than 6, or any string that contains the word is. We'll see lots of examples of this very shortly. And what you can do is that you can, well, there are also matchers for saying things like, that we expect the value to match this matcher and this other matcher. You can compose them together to form very complex assertions. And to make your assertions, your assert that methods more readable, there is a special matcher called is, which doesn't really do anything. It matches anything. It matches any other matcher that's given it, but it makes your methods easier to read. It makes your assertion statements easier to read. So here I have some code from an example. Notice that once again we're leveraging static imports heavily so that we can have more readable code. There is a class in Hamcrest called org-hamcrest-matchers, which lets you import a whole bunch of the matcher factory methods, things like equal to and contain strings, stuff like that. And we'll see lots of examples of that shortly. And then also you want to do a static import of the assert that method from matcher assert. Okay, so here's a test class that uses Hamcrest. So here is an example of using the Hamcrest equal to method. And notice that here I've stopped using that convention that has test methods begin with test. I just have is equal to. So I'll create two new integer objects from the string 1, 2, 3, and I will assert that int1 is equal to int2. This kind of method composition or methods calling other methods to have something readable takes a little bit getting used to, but once you do, you'll find that your assertion statements are much more understandable, and then you get much better errors. So actually, let's just go over to IntelliJ again, and I'll show you what it's like when one of these guys runs. Okay, there we go. Is equal to. Okay, so I'm just going to run this one method first of all and see that everybody's happy. Okay, everything passed just fine. But now let me change something so that it fails, and what you'll see is that the assertion error is much cleaner. So you get, okay, I expected it to be 124, but it was actually 123. Notice that in Hamcrest, the actual value is the actual value is on the right, the expected value is on the left. In JUnit, it's the other way around. So this is cool. It gives you pretty good stuff here. But honestly, I mean, assert equals in JUnit in this particular case would give you the same thing. Let me quick revert that change, and we'll go look at some other ones. Okay, so that's the equal to matcher. And by the way, is and equal to are those matchers that you talk about. That I've talked about. If you want to test that something is null, you use the null value matcher. If you want to test that something is the same object, instead of using assert same, you use the same instance matcher. And let's look at something a little bit more interesting. Here are some of the facilities, some of the matchers that Hamcrest has for working with strings. So I can say something like, okay, I want to assert I have a string, Hamcrest is awesome, and I want to assert that that string starts with Hamcrest, or that it ends with awesome, or that it contains a string is. I want to make sure that it is not the empty string, and I realize it's cut off here, but I also want to assert that the string is equal to ignoring case, all caps, Hamcrest is awesome. So let's go back to IntelliJ, look at that strings method again. I'll run it the first time to, I'll run strings the first time just to make sure that's passing. Cool. And now let's just change something that fails. Let's say, oh, I want to assert that the string starts with Hamcrest, not Hamcrest. Now when I run it, I get a much more detailed error message than I would with a plain old JUnit assert true. Right? Here again, that assert true would just have a message like, oh, I expected it to be true, but it was false. Now I get details about, oh, I expected a string that starts with Hamcrest, but instead I got the string Hamcrest is awesome. So here again, that level of detail makes it a lot easier to debug your unit tests when they fail. Okay, I think Hamcrest is just disturbing. I'm going to revert that change, run it again. So I hope that you're seeing here that what you get with Hamcrest is more readable code and then much more readable and detailed and useful error messages. Okay, we got a couple more to look at and then we'll be all done. Hamcrest also has support for asserting things when you've got a collection of objects, like a list or an array. It can make assertions about the contents of that list or the contents of the array. So for instance, here I have a list of strings and I want to assert that every item in that list is not null. Okay. I also like Hamcrest support for working with numbers. Again, here with JUnit, let's say I call some API and I expect it to return a non-negative number. Well, in JUnit, what I have to say is well, let's say return some value I would say assert true I greater than 0, greater than or equal to 0. If that failed, the error message that I get is expected true but was false. There again, not very helpful. With Hamcrest, you can say things like, hey, I want to assert that my value of pi is greater than 2. And if it wasn't, it would give me a nice error message that said, I expected a value greater than 2, but it was something else. The second assertion demonstrates how you can have you can test that a value is in a certain range. So that is both greater than 1 and less than 4. And yeah, I know as methods calling methods might be a little difficult to read and lots of parens and stuff like that. But I think it's pretty easy to see what that means. And because you're using English and not like ampersand, ampersand, there's not that translation between the Java language and the Boolean logic going on in your head. And maybe if you're dealing with round-off error or something, or you only need a specific precision, you can use this close to matcher. It says, okay, well, I want to make sure that pi is close to 3.14, and then the accuracy is hundredths. And finally, an example of using some of the array matchers. You can assert that okay, it has the array has an item 4, that its size is 5, that it's not empty, that the value 4 is in the array, stuff like that. So Hamcrest is very useful. Will make for better looking, easier to read unit tests, and then also if a unit test fails, the error message will be much more informative than just using plain old JUnit by itself. So in summary, Testing is a really good thing, and I can't stress it enough. The reason that that one of the first things that we talk about in advanced Java programming is unit testing is because I really believe that it'll make you a better Java programmer, a better software engineer in general, and it has lots of really great benefits. So testing will improve the quality of your software because you'll be able to verify it. It'll give you that confidence to try new things and to go faster. It demonstrates, you'll have proof that your software works as expected. I recommend that you test as you code. As a matter of fact, I recommend that you write your tests first using test-driven development. And we'll be seeing test-driven development, TDD, throughout the course. But feel free to go do a Google search and get more information about it beforehand. Because what testing gives you is that it gives you that confidence that when you make changes to your code, you can verify that you didn't break anything. Or if you did break something, you'll find out about it right away, not at the end after you've done all your testing. And to the people that say, oh, writing tests takes so much time, I would say that the investment that you make in writing tests reduces your debugging time. I think it's a net win, right? All the time that you spend debugging and trying to unwind in your head what's happening and everything like that. If you have unit tests that demonstrate all of that, you won't spend so much time debugging. And luckily, JUnit makes it really easy to write and run test cases. You're just writing more Java code. And Java code to test Java code. And finally, and maybe most importantly for some of you, testing will help you get an A in this course. Because here again, you'll know that you've done the right thing. And in all of the assignments, I give you examples of how to write unit tests for them. And that's it. So this has been the screencast on unit testing. Thanks again for watching Advanced Java Programming at Portland State University.